we are explaining the topic of chapter 12. It is multi-threaded programming. As we are familiar with what is a multi-thread, right? So simultaneously execution of two or more thread is called as multi-thread. Okay, multitasking is nothing but a multi-thread. Okay, now we will see this multi-threading concept. Although Java contains many innovative features, one of its most exciting is its built-in support for multi-threaded programming. So what do you mean by multi-thread? Multi-thread means at the same time we have to do more than one task, right? A multi-threaded program contains two or more parts that can run concurrently. So that is the same thing here suggesting. Each part of a program is called a thread and each thread defines a separate path of execution. So if you are doing multiple tasks at the same time, so here technically it is saying as run concurrently. Concurrently means executing at the same time. Then such a program is called thread and each thread defines a separate path of execution. Every thread takes different path for its execution. Thus, multi-threading is a specialized form of multitasking. So, multi-thread is one of a specialized form of multitasking. So, as you know, what is multitasking? What is multitasking? Simultaneous execution of more than one task. Okay. Now, we will see the fundamentals of multi-threading. There are two distinct type of multitasking: process based and thread based. So there are two kinds of multitasking exist. One is process based multi-threading and thread based multi-threading. It is important to understand the difference between two. A process, what is a process? Program in execution, right? A process, in essence, a program that is executing. Thus, process based multitasking is the feature that allow your computer to run two or more programs concurrently. As we know, the definition of a process is a program in execution, hence we can run more than one program concurrently. For example, it is process based multitasking that allow you to run the Java compiler at the same time you are using a text editor or browsing the internet. For example of this process based multitasking, we can compile our program, we are using our notepad and we can switch over to the internet, right? So I can also listen the song and I can type my program, I can execute my program and I can give some print task. So all these process will execute simultaneously. In process based multitasking, a program is the smallest unit of code that can be dispatched by the scheduler. In process based multitasking, a program is the smallest unit of code that can be dispatched by the schedulers. Okay, as we know what is the schedulers, right? Now we are moving to the next tasking is thread based multitasking. In thread based multitasking environment, the thread is the smallest unit of dispatchable code. Okay, so as we know what is a thread, lightweight process, right? So by using this smallest unit of a dispatchable code, then what we are executing, this means that a single program can perform two or more tasks at once. So if you are using the thread means a single program, okay, that can be used more than, that can perform more than one task at once. For instance, a text editor can be formatting text at the same time that is printing, as long as these two actions are being performed by two separate threads. Suppose if you are typing in your text editor, at the same time if you give the print, the typing and printing is done by the two tasks, two threads, and one thread is used for printing purpose and another thread is used for typing purpose. Okay, to type the text on your editor. So for these two actions we are using two threads. Okay, although Java program make use of a process based multitasking. Here Java uses process based multitasking environment. Process based multitasking is not under the control of Java. Okay, even though if you are using the process based multitasking environment, it is not in the control of Java. Multi-threaded multitasking is. Okay, the principal advantages of multi-threading is that it enables you to write very efficient programs because it lets you utilize the idle time that is present in most programs. Then what is the usage of a multi-threading? As we know, in your operating system, whenever several processes want to execute at the same time, then the dispatcher decides, right? CPU scheduling and job scheduling, as you know. So some of the process in waiting stage, in that waiting state, a program went for the process, right? The program went for the execution, right? Here at the same time specifying whenever the program becomes efficient means it lets you the idle time. So every process in a queue, it is holding some waiting time. At that time some other process will immediately enters and executes, right? As you probably know, most input output devices, whether they can be network ports, disk drivers, or the keyboards, are much slower than CPU. As we know, your console devices are very lesser performance than your CPU if you are having a good CPU, right? Got it? Yes, that is the thing here saying. Console devices are your input output devices or network ports or device drivers. You're saying, okay, or the keyboards are much slower than your CPU. CPU is fast because of your configurations. Okay, so it will accept any number of instructions or any number of threads or any number of process. Thus, a program will often spend a majority of its execution time waiting to send or receive information to and from your devices. So, hence, the program will spend a majority of its execution in transferring. Where it is transferring, as we have learned in your operating system, right? I don't want to repeat. It is a to and fro from device to device. Okay, from secondary device to primary device to secondary device, primary memory to secondary memory, and secondary memory to primary memory, right? Now we will see the thread can be in one of a several state. Okay, so you are seeing here thread process, thread state. Now you will see the thread state. Yes. Now what is the first state? Newborn state, right? And next it is running and runnable. Next it is blocked and it is dead. So if you are created a task, the thread is created. If thread is sent for an execution, thread is running. Okay. If thread is waiting for some events to occur, then you are suspending, sleeping and waiting methods. So that is called as an idle thread. At that time it has been blocked temporarily. Blocking means here temporarily blocked. Whenever it gets its appropriate event or time or anything, then it will resume, right? Whenever it comes to the resume or notify, the running process will comes for the runnable state, and here the dead or killed, it says the program has finished, the thread has finished. Okay, so first, what is the first state? Newborn state. The thread has created. After the creating the thread, it has to send for the execution. Whenever it sends for an execution, thread start running. Whenever it requires some events, it will wait for a waiting state. That waiting state can be defined by using these methods. Okay, so once if it gets that appropriate events or time controls, then the waiting process comes to the runnable state, and once again it comes to the running. Whenever the thread has finished its task, it goes to the stop. Stop method means completely finishing. That state is called as dead state. Okay, let us see here. It can be running, thread is running. It can be ready to run as soon as CPU gets a time. So it can be ready to run, that is runnable. It is waiting for ready to run. Okay, once it is ready to run, what CPU get, it start ready. Okay, and next, a running thread can be suspended, which is a temporary halt. Suspended means the running thread can be temporarily stopped for its execution. Okay, it can be later resumed. Resume means you can start the stopped process, stopped thread. Okay, a thread can be blocked when waiting for a resource. So you can make the thread as a block for some resource to require for that thread. A thread can be terminated, in which case its execution ends and cannot be resumed. So once the all the resources are available, all the process is required, whatever the resource is required, it is available. If the task is finished, the thread went to the stop state. It means the execution has finished. Okay, it cannot be executed further. Okay, along with thread based multitasking comes the need for a special type of a feature called synchronization. Also, this thread comes with a special type of a feature called synchronization. As we know what is the synchronization, right? Yes, which allows the execution of thread to be coordinated in certain well defined ways. If you are using the concepts of synchronization, then that threads must be cooperated. Several threads are executing at the same time, right? So whenever several threads are executing, they must be cooperated. If they must cooperated, we have to follow the synchronized techniques. Okay, here some of the methods as given. Sleep method, blocked for a specific time. Here the sleep method is there. We are blocking the executable thread for some time. And suspend, blocked until for further orders. Suspend means it is waiting for further orders to get. And wait, blocked until certain condition occurs. If you are using the wait method, all these are the method. Please observe here. Start is a method, suspend is a method, sleep is a method, wait is a method, and resume is a method, notify is a method, and yield is a method, and stop is a method. Okay, so by using these different methods, this is a very important question. Sometimes it has asked in 2 marks and sometimes it has asked for 6 marks. Okay, so this question is very important. Okay, now we will see thread class and runnable interface. Okay, Java's multi-threading system is built upon the thread classes and its companion interface runnable. Okay, so here the Java, if you are developing a threads class, then we have to suppose to use some of thread classes and its interfaces. So that class is called as a thread class and interface is runnable. Runnables are the interfaces of a thread. Okay, both are packaged in java.language. Where does this interface and this class and this run interface is available? In your java.lang packages. Okay, thread encapsulates a thread of execution. Here encapsulation means what? It protects from a thread execution. So this class thread encapsulate from of a thread of execution. When a thread is executing, it will be protected through from this thread class. Okay. To create a new thread, your program will either extend thread or implement the runnable interface. So this is the question which is asking for every time how to create. What are the two ways of creation of threads? We will learn in shortly. That is very important. Okay, please give more attention on this topic. Okay, the thread class defines several methods that help manage threads. Okay, it consists of several methods. By using that methods, we are managing the threads. Let us see what are the methods available and how we are managing. Okay, yes, whether it is visible, right? Okay, first final string get name. What is the first method? Get name method obtains the thread name. If you have provided the any name to your thread, if you want to access the name of the thread, then you are using get name method and its return type is a string, and you can also define it as a final means constant. And next one is get priority method. Whenever several threads are execute, we have to get the priority of the threads. Okay, priority means preference. Obtains thread priority. Its method is get priority and its return type is int, and it you can also specify it as a Final means constant. Okay, next this two question is asked for 2 marks and 4 marks, and sometimes it is asked for 7-8 marks also. Okay, final boolean is alive. Let us see is alive, and you just observe the meaning. Determines whether a thread is still running. Is alive means whether the thread is running. It checks whether the thread is still running or not. Okay, and what is its return type? Its return type is boolean, and it can also be declared as a final. And next one is of final void join. Please observe here the join method is there, but you just observe the definition. Waits for a thread to terminate. What is the purpose? Join method. Join method is not used to join the threads. It waits for thread to terminate, thread to finish. Okay, it waits for thread to finish. Got it? Yes, finishing means close, right? So that is the usage of join method. Don't understand that combining of two threads. Okay, is allow method means we are checking whether the thread is still running. Void join method means we are waiting for the thread to finish, thread to terminate. Okay, thread to close. Now void run method, this is the entry point of the thread. If threads are starting means, if after the starting of a thread, whether thread is running or not, executing or not. So if you want to identify that, then you have to supposed to call this run method. Until unless this run method, your thread doesn't runs. Okay, and next sleep method. Here sleep method, it is a return type is void, and you can make it as a static. It is not belongs to any particular one. You can specify, you are not making it as a specific. Hence you can make the usage of this sleep method. Please observe here, sleep method means long milliseconds are given. Suspend a thread for a specified period of milliseconds. You can make the thread to wait for a specific period of time. Okay, you can make a thread to wait for the specific period of time. Okay, so that is also in milliseconds only, right? Here it is specified as a long milliseconds. And next one is the starts a thread by calling its run method. Whenever you calls the start method, automatically run method will execute, the thread starts running. Okay, so these are the methods. This question is asked in one of a paper, so you are not supposed to neglect it. Okay, now all the processes have at least one thread of execution, which is called as a main thread, because it is the one that is executed whenever program begins. As we know, all the process consist of several threads, but at least it consists of a one main thread that runs up for all the times. Okay, and also it indicates the beginnings of the thread. Thus the main thread is the thread that all of the preceding example programs. From the main thread, you can create other threads. From the main thread, you can create other threads also. Okay. Now let us see creation of threads. This question is asked for the 8 marks or 6 marks. So you should pay more attention for this. Creating threads. Threads are implemented in the form of objects that contain a method called run. So you can also implement your thread by using a form of an object by using which method? Run method. It is the only method in which the thread behavior can be implemented. By using this method only, you can implement that thread. Okay. Then what is the general form of a run? The general form of a run is public void run. Okay, it consists of a run method. In the run method, you are specifying the implementation code, that means what action supposed to do. Okay, yes, here it is saying the same thing. The run method should be invoked by an object of the concerned thread. This can be achieved by creating the thread and initiating it with the help of another method called start. So if you want to make the run of a thread, then you have to supposed to call start method. For example, I'm giving a general example, not as an uh, technical example. Okay, for example, you are having bike, right? Bike or scooter. To start the scooter, then what you have to supposed to do? Yes, anybody? Yes, as we know, we have to switch on the key, right? If you switch on the key, then at a time, every part of your system, every part of your engine is get ready. Got it? So now you are starting that bike. If you once start, then only you can ride your bike. Riding means you can run. Got it? If you doesn't start the bike, can you take a ride? No. Got it? So likewise. So if you are using the start method, then only the run method will activate it. If you doesn't use the start method, then run method won't execute. In the same sense, in the threads also, you have to supposed to use start method. Whenever you are calling the start method, automatically run method will execute. Okay. Now we will see this important question: how threads can be created. Threads can be created in two ways. Threads can be created by two ways. Let us see first one, by creating a thread class. How we can create? We are creating a thread class. Define a class that extends the thread class and override its run method with the code required by the thread. So you are defining a class and also use the keyword extends. Extends means inheriting. Which class you are inheriting? Thread class. Afterwards, what you are doing? You are overriding. Overriding means subclass method will override superclass method. Okay, override its run method with the code required by the thread. And second one is by converting a class to a thread. Then say, what is the second method? You can convert a class to a thread. Okay, so then how to convert a class into a thread? We have to follow these steps. What is the first one? Creating a thread class. What is the second one? Converting a class to a thread. We have to convert our class into a thread. Okay, so to define a class that implements a runnable interface, if you want to convert a class into a thread, first you have to define a class which implements runnable. Implements keywords you are using means you are inheriting interfaces. Which interfaces you are inheriting? Runnable interface. Okay, yes, you have to define a class that implements runnable interface. Okay, implements means you are inheriting. What you are inheriting? Interface. Which inheritance you are inheriting? Runnable interface. The runnable interface has only one method, run, that is defined in the method with the code to be executed by the thread. This runnable interface consists of one of the method. That method is the run method. By using that run method, you can develop the implementation code. After the implementation of a code, you can specify what the thread has to supposed to do. Okay, the approach to use depends upon the what the class we are creating requires. So it is based upon our requirement. Okay, so if you are developing a gaming program by using Java, let us understand, for the gaming program it requires several threads. Okay, for example, I'm considering just for as an example, not don't take it as a serious. Okay, just for your understanding purpose, suppose you are playing the subway surf. So same path is repeating, one object is moving, and trains are coming, coins are coming, right? So to display that moving by object, one thread is required. For displaying the path, one object is required. For playing the thread is required. For showing the coins, a thread is required. For policeman, one thread is required, right? All these several threads are required. Got it? Clear? So it is the same thing here we are approaching. Okay, it is our requirement. Based on our requirement, we have to specify how that thread has to work. If it is if it requires to extend another classes, then it is necessary to implement runnable interface. If you want to extend this concept to another class, then what we have to supposed to use? Runnable interface is best. Okay, Java classes cannot have two super classes. As we know, Java classes doesn't have two super classes. Now let us see the first method. What is the first method? Extending the thread class. This is our first method, right? How to create the thread class? By creating a thread class. And the second one is by converting a class to a thread. Now I'm extending the thread class. There are 3 steps to make our class runnable interface. Okay, we have to make our class as a runnable interface. To make the runnable interface, we have to suppose to use uh, 3 steps. What is the first step? You have to define the class as extending the thread class. First, you have to define the class and it has to extend the thread class. Implements the run method that is responsible for executing the sequence of code that the thread will execute. Afterwards, you have to specify the run method. In that run method, you have to specify the responsible executable code, and that code also specifies the sequence of code that the thread will execute. Okay, create a thread object and call the start method. Next one is you have to create the thread object and call the start method. By using that object, you are to supposed to call start method to initiate the thread execution. Okay, let us see the first method. How we are doing. Declaring the class. First the class can be extended as follows. I'm using this as a first method, okay, not as the second method. Class name extends thread. What is the name of the class? My thread. This class inherits the features of thread class. Okay, afterwards what you have to supposed to do, you have to implement the run method. You have to develop the code for run method. The run method has been inherited by the class mythread. So this run method has been inherited by the class mythread. We have to override this method in order to implement the code to be executed by our thread. Okay, so whatever the code you are specified, that will be override by this method which is presented in your superclass. The basic implementation of run method is as follows. Then how to write this run method? Public void run, not as an a, I'm just, it has given it as a, it is not there. Okay, public void run. Next, it consists of a body of a codes, and we will see in coming slide as a example. When we start a new thread, Java calls the thread run method. In thread, all the action take place in thread. Whenever you are creating a new thread, Java calls run method. By through that run method, we can run whatever the action specified, whatever the task we have to supposed to do. Okay, now let us see starting new thread. Then how to start a new thread? The following statement actually creates and runs an instance of a thread class. Now we are creating the object of a thread class. After creating the object of a thread class, we have to start that thread, right? By invoking object of a thread dot start method. Okay, if you observe here, my thread is the last. We have created a class. For that class, you have created an object a thread. How you say? Because you are using new my thread of, right? This is the class method, right? And you are creating the object, right? Now object dot start, a thread dot start, automatically this run method will invoke. Whenever you call the start method, that run method will invoke. The first line instantiate, here the saying the same thing. First line instantiate the new object. The thread is newborn state. Whenever the object is created for a thread, it is a newborn state. The second line calls the start method, causing the thread to move into runnable state. Whenever you call the start method, it is getting ready. Okay, that is called as runnable state. Then the Java runtime will schedule the thread to run by invoking its run method. Whenever it is scheduled for run method, it is in running state. Okay, got it? If you are creating the object for a thread class, means it is a newborn state, thread has created. And whenever you are calling the start method, means you are making ready of your thread. Whenever run method is called, means the waiting thread is getting into execution. Okay, clear? Yes, yes. Okay, now we will, to better understand this concept, we will see this example. Now what is the name of a class? Class A. Class A extends thread. It means it is inheriting the class thread class. Okay. Okay, now afterwards I'm writing the public void run method. What I'm doing, I'm writing public void run method. Here for int I is equal to 1, I less than or equal to 5, condition true, and I'm displaying thread A for first time, and I will be incremented, and second time, third time, fourth time, and fifth time. Afterwards we are exiting from A. Okay, here the run method ends and here the class here ends. I'm taking one more class, class B extends thread. It is also inheriting the threads features. Now I'm writing the same public void run method, and I'm taking here the counter variable as int j is equal to 1, j less than or equal to 5, j plus plus. Okay, and it will also execute for the 5 times. Okay, here the class B ends. Now I'm coming here, class C extends thread. Okay, I'm taking another class. It is also inheriting the thread concept, and here also it consists of a public void run method, and I'm taking the same for loop with a different variable. Okay, so it also execute for 5 times. Now please observe this A, B, C, class A, class B, class C. These are the three different threads. These are the three different process. Whenever these process execute simultaneously, then how it executes in your system. Okay, as we have learned how these process enters into a queue and how operating system allots the job for the execution in your operating system, right? Now let us understand class A, class B, and class C is the three different thread. If three different thread starts at the same time, while starting for that time, it has to wait for a minute time. In that minute time, one of a process is entering and it will be finished. Okay, whenever it waits, another process enters and finish. Okay, so here hope you have understand this class A, class B, and class C, and I am moving to another class. Is there in class A, class B, class C, is there any main method? No, right? Now I'm writing the main method class. What is the name of a class? Class thread test. Okay, it consists of a main method, public static void main string args. Now please observe here, new A dot start. It means you have created the object for a class A, that is A. Here new A of means you are creating the object of class A and you are calling the start method. Whenever the start method is called, this run method will execute. New B of means for the class B you have created the object name as B. Okay, don't get confused. Don't get confused. And you are starting that method, automatically class B runs. Okay, and new C of dot start, so once again your C is also started. So these three processes has started at the same time, then how our output will looks like? Our output will look like, first A is execute for 2 times and B will be execute for 2 times and C will be execute 2 times. Whenever A executing after 2 times, it will be in waiting state and B is entering, and after that C is entering. Got it? Clear? So likewise these three, so we don't get the same output. We don't get the same output. For example, I will show you the running of this program. Okay, I'm copying, minimizing. Now I'm taking notepad. You will understand how it will execute. Okay, I'm taking new file. Yes, I'm pasting now. Got it? And I'm coming here and I'm copying from here onwards and coming here and pasting. And I'm coming here and pasting. Got it? Class A, class B, class C is of the same logic. It has to supposed to execute for the 5 times, and here the main class has taken, right? So I'm copying in the same one single notepad and I'm pasting, right? If you are getting the confusion, as we know how to create the thread, what is the name of a class? class A, right? So A, for example, for your understanding purpose, if you get confusion of this, then I'm writing how to do this one. Okay, don't get confused. This is the same which is created as an object. Okay, so I'm creating for class A, I'm creating object A is equal to new A of. Got it? So this is the object, right? I'm creating for the class B, I'm creating B is equal to new B of. So this is the object creation. For the class C, I'm creating C as the object, new C of, right? After creating the object, what we have to supposed to do? We have to start that thread. To start that thread, object dot start method, object dot start. Okay, you have to call start method. Clear? And next, object dot start method. Okay, and C dot, and next one is C dot start. Okay, yes, that's it. So this is the creation of object and you are running the object, right? You are starting the object. So this is two statement can also be done like this also. Okay, don't get confused. Now how to save this file? Class thread test. Okay, now while doing we will get errors. Why? Here already we are seeing double quotation mistakes, right? Okay, let me modify this first, otherwise I will get an error. As we know, this is the errors, right? Yes, yes, this is the errors. Yes, got it. So I'm copying the class which consists of a main method copied. Whether you want to show, let me see. I'm ensuring that where I'm supposed to save. I'm going to save file, save option. While saving, you have to ensure that you are storing in your appropriate directory, right? It is JDK 1.4 bin. Here the file name is asking. I'm typing thread test dot java, right? Afterwards, I'm clicking the save option. Clear? Yes. Okay. Now minimizing, and let me take my command prompt. Already you know how to take it. I don't want to explain it, right? Now I have to log out from the default directory. I have to log in into my directory. Yes. Now compile it. Java C. What is the name of the file? Thread test. Compiling. Okay. Thread test. Thread test. Right. Thread test dot java. Let me check, is there any errors? It is a checking. So this much of errors has identified in the line number 12, 18, 18. Okay, so that is why I'm using here. Where is the 12? This is the 12, right? uh, Nothing there. Anyhow, let me take 12, 18, 18. It is also correct. No mistakes are there. Okay, let me save it first and once again compile it. So it is in the line number 17. illegal character 1717, not a statement. Okay, let me check what is the 17th line. Here it is not having anything. It is correct. System dot out dot println 17th line doesn't have any mistake, but it is showing as a mistake. Okay, let me say once again. There nothing is there. Okay, let me compile once again. It is showing line number 17. Some spaces are there, so let me remove that space. Okay, now fine. I save it. I check. Now it is not there, right? Clear? While copying directly from your PPT, these kinds of errors will comes. So it is a problem. Okay. Now I am running Java thread test. Whenever I am running, it is showing the output, right? You are identifying here. First, it has enter I, J, K. So ABC thread has started at the same time. After that, ABC, 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 ABC. So it doesn't get the same order whenever I'm running for multiple times. If I run that, here it is coming ACB, right? First it has started C. Got it? Clear? Why? We do not know which thread has entered for the execution first. Here if you observe here, B is exiting first, right? Here the B thread has started, C thread has started later, that way. Here we are not setted any priority. If you set the priority, according to the priority, what happens? We came to know which thread is executing first and which thread is executing next and which thread ending last. Okay, so hope you understand this program. In this program, what we have done, this class A, class B, class C are the three different threads. I have started three different threads at the same time, but according to the CPU convenient time, operating system sends the threads for an execution. Got it? So as we know what is the dispatcher and dispatch latency. So likewise, your threads are executing. Got it? Yes, that is why here we have placed true of output. Based on this true of output, you are getting different output, right? You also seen this. You don't expect the same output when you run your thread concept. Okay, yes. So this is one process, one process, one process. Three processor get started at the same time. We do not know which process enters first and which processor finished first. Okay, so that's it. It is a just like as an a just as an a creation of thread. Okay, so how we have created it is inheriting the features of extends concepts. This is the first method, creation of thread using thread class, extending thread class. Okay, we will continue in the next class, and this question is asking for several times, and this question is also asking for several times. Hope you have understand this concept. You have to give more attention on this, and in our labs also two programs are exist. You have to give more attention on this topic. Okay, we will see in the next